Welcome back. This is Algebra 1 Honors. This is Mrs. Rubright, and today's lesson is 5.5, Solving Linear Inequalities. A linear inequality in two variables, such as 2x minus 3y is greater than or equal to 6, results when you replace the equal sign in an equation with a less than, greater than, less than or equal to, or greater than or equal to symbol. A solution of an inequality in two variables, x and y, is an ordered pair, x comma y, that makes the inequality true. All right, so graphing a linear inequality. Graph the solution set for 2x minus 3y is greater than or equal to 6. All right, so we're going to start by graphing 2x minus 3y equals 6. The inequality is true for every point on this line because the inequality symbol is a less than or equal to. So when it's less than or equal to, it's a solid line because it includes those points. The line is included in the solution set. Like all the points on the line are part of the solution, right? If it was like this, that would be dotted line. So if it's less than or greater than, it's a dotted line. The points on the line are not in the solution. All right, so if it's greater than or equal to or less than or equal to, then it is solid. It includes those answers. Greater than and less than does not include the answers. Okay, so they want us to find our x-intercept. Our x-intercept is when y is 0. When y is 0, our x-intercept is at 6 divided by 2 is 3. And our y-intercept is when x is 0, divide by negative 3 on both sides, and you get negative 2 for our y-intercept. We can also do a third point just for good measure. So 0, negative 2, 3, 0. And we can put in, say, negative 3. If I plug in a negative 3, what do I get? I get negative 6 plus, minus 3y is greater than or equal to 6. And we'll do that as if it was an equal to, right? Add 6 to both sides, 12. Negative 3y is equal to 12. So y equals negative 4. Over to negative 3, down, 1, 2, 3, 4. It does fall on that line, so we know we didn't mess anything up. Okay? So, now what we need to do is we need to look at our equation to know, do we shade up, do we shade down, like where do we shade, where are our answers? So we know our answers are everything on that line, but are they also everything above it or everything below it? So we can test some points. So if I test 0, 0, and I plug that in, I'd have 0 is greater than or equal to 6, right? If I plugged in a 0, 0. Is that true? Is 0 greater than or equal to 6? No, it's false. So I'm going to shade this way because that is not part of the solution. So they're just showing you if you plug different numbers in. So like if I plugged 5, 0 in, I would have 2 times okay, so 5, 0, 0, 3, 4, 2, 6, 1. 10 minus 3, or minus 0 is just 10. 10 is greater than or equal to 6. True. So you shade to include 5 zeros. So 5 zeros here, and we shade to include it. Showing you guys here, so that would be below, right? It's located below the line. That'd be negative 9 is greater than or equal to 6. False. This is above the line, and we don't shade to include it. 0, 3 is up here, and it's not an included solution. 8 minus 6 is 2. Is 2 greater than or equal to 6? No. False. This is located above. And you see how it's not included. 12 minus 3, 9. 9 is greater than or equal to 6. True. This should be located below because it should be included in the solution set. 6, comma 1 it is. It's right here, and it's definitely a solution. All right, so I want to kind of show you guys another way of doing this too. So the solutions lie on or below the line, okay? But I want to show you guys, if you put this into y equals mx plus b, I think that's the easiest way to do these. So 2x minus 3y is greater than or equal to 6. Okay, so if I'm solving for y, I'm going to subtract 2x from both sides. Negative 3y is greater than or equal to negative 2x plus 6. I'm going to divide by negative 3 on both sides. Anytime you multiply or divide both sides of an inequality by a negative, you flip your sign. So this would be 2/3 x minus 2. Do you guys see how I got from here to here? So that means that my y-intercept is negative 2. My slope is up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Do you guys see how I could graph that pretty quickly and easily? Because it's an or equal to, I know it's a solid line. And then, this is my trick. As long as my y is on the left by itself, I can do an arrow trick. So my y values are less than or equal to that line. So my y values that are below that line, less than or equal to that line, I shade down. Pretty cool, huh? Just based on this. The y values, you look at your line, and you want the less than or equal to that line. Shade below. Make sense? So let's do another one. Shade and test. Shade the set of solutions to the inequality. The shaded region and the boundary line line up to make this graph. Okay, so wait, didn't we just do this? Is this the same problem? It's the same problem. We just graphed that on the last page. So once again, we had y is less than or equal to 2/3 x minus y is less than or equal to 2/3 x minus 2. So negative 2, up 2 over 1, 2, 3, up 2 over 1, 2, 3, down 2 over 1, 2, 3. Here's our line. It is a solid line, and we shade below. How would the graph of 2x minus 3y is less than or equal to 6 be like the graph? Okay, so if they basically just switched your symbol, well then instead of shading down, you shade up. Same line, but shaded above instead of below. Right? Would the points on the boundary line be included in the graph? On this graph? No, because it's not an or equal to. A student says that you shade above the boundary line when the inequality is greater than or equal to, and you shade below the inequality if it's less than or equal to. Use the example to explain why this is not always true. It is always true if your y is isolated on the left, but if your y is not isolated on the left, it doesn't always hold true. It's only true if the y is isolated on the left. If the y is not isolated on the left, then it won't always be true. Okay? So, graphing a linear inequality into variables. So we have this inequality. Write the equation of the boundary line. So personally, I think the easiest way to do this is to just put it into y equals mx plus b. So I'm going to do negative y is less than negative 7x plus 13. Divide by negative 1 everywhere. Y, because I divided by a negative 1, I flip my symbol. 7x minus 13. Y is greater than 7x minus 13. Alright, so negative 13, that's not even on the line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Up 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. Up 1, 2, 3, 4, 5, 6, 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. All right, so this is not an or equal to, so it's a dotted line. It is not an or equal to, so it is a dotted line. Is everyone clear with me so far? You guys see how I changed this into y equals mx plus b? I solved for y. I subtracted 7x from both sides. I divided by -1 on both sides. Because I divided both sides by a negative, I had to flip my inequality symbol. So now, my y values are greater than the line. So, see the y-intercept? We're shading above the y-intercept, so it's going to be over here. So any point that falls over here is going to be included in our solutions. Make sense? You could also test points. If I tested 0, 0, it better work. So I'd have 0 is less than 13, true. So it shades to include 0, 0. Right? You can always test points. So if you're doing the testing point, why is 0, 0 a good choice to test a point? Because it's easy to plug in, right? It's not a good choice if it's on the line. For the graph of x is greater than or equal to 4, the boundary line is a vertical line, x equals 4. Would you shade left or right of the boundary line? So let's think. Y values, x is 4. Solid line because it's greater than or equal to. Your arrow is pointing this way, it shades this way. Your x values are greater than or equal to 4. It shades to the right, because it's values that are greater than or equal to 4. If I plugged in a 0, 0 equals 4, it's not going to work, right? So, but I mean, you can't really. 0 is greater than or equal to 4. Is 0 greater than or equal to 4? No, so it doesn't shade this way. If I plugged in a 5, 5 is greater than or equal to 4, it shades this way. Okay? Let's do a couple practice problems. So our first practice problem. Y is greater than or equal to 2. So where is y2? Is this going to be horizontal or vertical? Horizontal. Or equal to. Solid or dotted? Solid. Good. You guys are on a roll. This is where y is greater than or equal to 2. So if my y values are greater than or equal to 2, above or below, where are your y values larger? Above. X is less than -3. Where is x -3? So I go to my x-axis, -3. It's an open dot because it's not an or equals to. Your x value is -3 everywhere on this vertical line. Dotted. It's a vertical dotted line because it doesn't equal these points, right? And then your x, use your arrow trick, guys. Your x is less than -3. Do you see the arrow? As long as your variable is isolated on the left, do you see the arrow trick? It's telling you to shade this way. Your x values are less than -3, so more in debt than -3. All right, so here's another one. You guys can either use your x and y intercepts, or I like to personally put it into y equals mx plus b. So 4y is less than -x plus 9. Divide by 4 everywhere. Y is less than -1/4 x plus 9/4. What is 9/4? 2.25? 1, 2.25. Down 1 over 1, 2, 3, 4. Down 1, 1, 2, 3, 4. Down 1, okay, so up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. All right, so here's our line, dotted or solid? Dotted, right? All right, so y is less than. Y is less than. Shade down. Let's double check. If I plugged in 0, 0, I'd have 0 is less than 9. Is that true? True, so it should include 0, 0, right? Double check. All right, so on the next one, I would have negative 2y is greater than or equal to negative 2x plus 5. Divide by negative 2 everywhere, which means I have to flip my sign. 5 over 2 is 2.5, right? Negative 2.5. Slope of 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Solid line. Because it's an or equal to. Y is less than or equal to. Shade down. Let's just double check. If I plug in 0, 0, it better not work. 0 is greater than or equal to 5? No, it will not include 0, 0. And it doesn't, so we know that we didn't screw anything up. Okay, it's good, right? I want you guys to try number 5 with your table partner. Try number 5 with your table partner. So for y equals mx plus b, it should be y is greater than or equal to 1/2 x plus 1/3. So you go to a y-intercept of 1/3, rise 1, run 2, rise 1, run 2, solid line, greater than or equal to, shade above. Let's double check. If I test 0, 0, it better not work. 0 is greater than or equal to 2? Nope. It does not include 0, 0, and my graph does not include 0, 0. And with your table partner, try the very last one. Y is less than 7x minus 13. You had to flip the sign when you divided by a negative 1 on both sides. It is a dotted line because it does not include the line. And then our y values are less than the line, so these y-intercepts are above it, these y-intercepts are below it, so I shaded to the right or below it. And then just to double check, let's just make sure 0, 0 does not work. I'd have 0 is greater than 13, that does not work, and it's not shaded to include 0, 0, so we are good. That is everything on your lesson on 5.4. Which was, 5.5, solving linear inequalities. Your homework is page 303 and 304. Please like and subscribe and have a wonderful day.